Good morning, class. My name is Abdullah Sadibi, and today we'll be reviewing for the Calc 1 final. The first topic today is changing from radical to exponential form. The purpose of changing from a radical to an exponential form is to make the problem look much easier. We're going to look at this first question over here, which has radical x. Radical, this portion right here is a radical sign. Now, working with radical x, how you change that into its exponential form is simple. It equals x to the 1/2. That's just a rule. But it's different when you have something like the cube root of x. With the cube root of x, you need to remember that you have an imaginary 1 with the x, and the 3 will be acting as its denominator. So when you rewrite it in its exponential form, it'll equal x to the 1/3. You use the same concept when you have the cube root of x squared. 2 is already acting like the imaginary 1, so you don't need to worry about an imaginary 1. The 3 will be the acting denominator. Now this in its exponential form will be x to the 2/3. Now that's how you go about changing from radical to an exponential.
Okay, for today's Cal 1 review for the final, we'll be discussing trig identities. So first, what you want to do is write your 6 basic trig identities, which is sine, cosine, tangent, secant, cotangent, and cosecant. Alright, so first, what you want to do is basically write the derivative of sine x, which is cosine x. Then next, you want to find the derivative of cosine x, which is sine x, but negative. After that, we're going to find the derivative of tan x, which is secant x squared. Well, secant squared x. Then the next one, you want to find the derivative of secant x, which is secant x tan x. After that, we're going to find the last 2 derivatives. The derivative of cotangent, is cosecant squared x, and then the last derivative is cosecant x, which is cosecant x, cotangent x, and these are your 6 trig identities that you need to know for the 6 basic trig functions.
Hello class. Today we'll be going over the chain rule and how to use the chain rule. So basically we have these 2 questions. We're going to start off with number 1. We have y is equal to 2, 3x plus 1 all squared. What we're going to do is find the derivative. In order to find the derivative, you must know how to utilize the chain rule. That's what I'm going to show you right now. So the first thing I'm going to do is write down y prime, the prime indicating derivative, is equal to, we're going to use the power rule. We're going to bring this 2 down in front of the 3x plus 1. So bring the 2 down, rewrite the 3x plus 1 is to the first power. And we need to take the derivative of the inside. This is where the chain rule works, or comes into play. The derivative of the inside, which is 3x plus 1, we're going to multiply by dx. Now we just bring everything down. You bring this 2, the 3x plus 1, bring it down. We take the derivative of 3x plus 1, which is 3. So bring your y prime down. 2. Again, the derivative of 3x plus 1 is 3. Multiply the 3 by the 2. Then go this way. That's pretty much how you take the derivative using the chain rule. Now we're going to go on to the second question. Now if you remember from the first topic, which is changing from radical to an exponent, you're going to see how this comes into play. So we have radical 2x plus 1. Looks kind of complicated. We're going to make it look easier by rewriting the problem as y is equal to 2x plus 1 all to the 1/2. This is our new problem, both the same problem. We're going to use the chain rule again. Taking the derivative, it'll be y prime is equal to, bring the 1/2 in front using the power rule, 1/2, rewrite what you have inside, 2x plus 1, 1/2 minus 1, negative 1/2. And the most important part, multiply by the derivative of your inside, times d over dx of 2x plus 1. Do the math. We get y prime is equal to 1/2 2x plus 1 to the negative 1/2 times 2. Multiply the 1/2 and the 2, those are your like terms. Y prime is going to be equal to 2x plus 1. That's how you utilize the chain rule to solve the basic derivatives.
Alright, so today's part 3 of Cal 1 review is rewriting exponential functions. So basically what you're going to do is take you have your example problem, which is integral sign 1 over x squared. And basically to rewrite it, what you're going to do is take the x squared and bring it to the top. And whatever the exponent sign is, you're going to make it negative. So down here is the answer of how you rewrite it. And basically all you're doing is bringing this to the top, changing your sign, and that's how you rewrite exponential functions.
Hello class, today we'll be talking about evaluating the limits. Now when you're evaluating limits, the first thing you're going to automatically do is something called direct substitution. What does direct substitution mean? I'll give you an example. We have the limit as x approaches 1 of x squared over 4. When we use direct substitution, we're plugging in our limit that we're approaching 1 into x. So over here you can see we have 1 squared over 4. Do the math, 1 squared is 1 over 4 remains 4, and your limit is 1 over 4. Now, there are a couple of rules also when you have direct substitution. In some instances, you can get 0 over 0 as an answer, or you can get any number over 0 as an answer. We're going to move over to these examples so I can explain to you exactly what that means. So, the same thing, direct substitution. We have the limit as x approaches 1 of 1 minus x over 1 minus x. If we substitute in 1 for x, you have the limit, you have 1 minus 1 over 1 minus 1, which is equal to 0 over 0. Anytime you have 0 over 0, you use something called L'Hopital's rule. We're going to write down L rule. And what L'Hopital's rule indicates is that you're allowed to take the derivative of the numerator separate from the derivative of the denominator and try it again. That's L'Hopital's rule. Now if you get a number over 0, we're going to go back to this example so I can show you. We're doing direct substitution again. We're plugging in 1 for x. You get is equal to 2 over 1 minus 1, which is equal to 2 over 0. We have three possible answers: plus or minus infinity, or, depending on what answer you get, D and E, which stands for does not exist. Now we're going to switch over and show you how you evaluate limits for graphing.
Alright, so here is evaluating limits, but only difference is you're doing it with graphing. So first, what you want to do is write the limit, which is natural log x. And basically you're going to take the derivative of that, which gives you 1 over x. Next, what you're going to want to do is find the derivative of e to the x. Whenever you have e to the x, it's always going to be equal to e to the x. Then your next step is going to be to graph the limits. First you grab your limit e to the x, and then second you're going to want to graph your limit natural log x. And as you can see, after you graph, e to the x is approaching positive infinity, and natural log n to the x is approaching negative infinity. And this is how you graph to find limits.
Hello. Today we'll be evaluating trig functions using the unit circle. This is not the complete unit circle, but it's enough for me to get the point across and show you exactly how you utilize this unit circle to evaluate trig functions. So you're looking at this unit circle, you see 0, 1, 1, 0, 0, negative 1, negative 1, 0, and underneath you see cosine, sine, and so on. You have pi over 2 over here, 0, 2 pi, 3 pi over 2 and pi. What does all this stuff mean? I'm going to explain it to you right now. So 1, 0, and 0, 1 right here, all of these are coordinates on the unit circle. Okay? Pi, 2 pi, pi over 2, 3 pi over 2 are values. Cosine and sine is how we're coming to play. Say you get a question on the test. What is sine pi? Oh, do that one time. Sine pi over 2 is equal to what? Sine pi over 2. I see pi over 2 over here, right? I see cosine and I see sine. The left-hand side, or your x values, deal with cosine. The right-hand side, or your y values, deal with sine. Sine pi over 2 is equal to 1. Now, what if you were to ask, so what's cosine pi over 2 equal to? Well, I see pi over 2. I see the cosine on the left-hand side, or your x value, must equal 0. And so on. You can go around the entire unit circle. You have a question, for example, cosine of pi. You look at cosine over here. You look at pi over here. Cosine is on the left-hand side, or your x value. The answer is negative 1. We want sine of 3 pi over 2. You see sine. You see 3 pi over 2. Sine is on the right-hand side, or your y value. The answer is negative 1. This is a basic way, basic understanding of how to utilize the unit circle to solve for trig functions.
Alright, today to close our review for Cal 1 final exam, we are going to go over the inverse function. So first what you want to do is write your regular function, and then step 2 is to switch x and y, because every xy has a yx partner. So when you rewrite it, you go from y equals negative 1/3 x plus 1 to x equals negative 1/3 y plus 1. Then after you rewrite it, the next step is to solve for y. First step, what you want to do is multiply by 3 to ditch out the fraction. After you do that, you ditch the 3 by minusing 3 from each side. That will give you 3x minus 3 equals negative y. Alright, so after you have 3x minus 3 equals negative y, bring it up and rewrite it. Bring the y to the outside to get rid of the negative. So then you rewrite it as y equals negative 3x plus 3. Then you substitute in your inverse notation, which is f inverse x equals negative 3x plus 3. And this right here is your inverse function.